Hello and welcome back to the Alteryx Weekly Challenge. Me, Nick Bignell. This is challenge number 108. HeLa cell manipulation. So what is HeLa? Well, HeLa is short for Henrietta Lacks, and she has a very famous contribution to science in that some cancer cells that she has are more resilient and able to replicate themselves outside of the body. So they now use those cells on lots and lots of experiments and research to find a cure for cancer, really. And other things as well. So you are a laboratory researcher and you gain access to the cell. You are given 1,000 cells to grow a sufficient sample. The cells must be in a solution area. They will cease to multiply once they reach their top density, which is 400 cells per milliliter. We have 30 milliliters to work in and 1,000 cells in the solution. So how long will it take? Basically, what's the date range between start and finish? So if we go to the Alteryx challenge, this is it. This is the start file. We'll see in here we've got split count, the cell count, the solution, and the start date, which is 9 o'clock on the 19th of March 2018. Not sure why this has got macros or interface, particularly interface with it. Not sure. But what we're trying to get to is the begin date and the end date. Okay, so we're trying to work out how long it would take to do that. So I think the first thing we can do with this is work out what the target is. Our target is 400,000 cells per milliliter, and we have 30 milliliters to fill. So that's fairly easy to work out. And we can basically, I'm thinking is we build out the rows for every split and stop when we reach that number. So great. So we want to call it target count, and we'll simply put 400,000 times. We can just use the solution milliliters, 30 mils, but let's make this a number. And if we run that, okay, we've got our target, which is 12 million. Okay, so let's just have a look at this, what sort of data. Okay, so it is already split out into bytes and integers and the date time here, so that's handy. So we don't have to do that. So we want to multiply this or increase a row until this, if we double this each row until it reaches this number. I'm thinking that's the way to do it. So let's bring that in, generate rows, and we want to do row count is good enough, and the initial expression is 1,000, and the count, what we want to do is, so it's basically row count. If we want to do this count, just call it count, I think, and we want to use that as the expression, and it's count times 2 because it doubles every time it doubles. Okay, so times 2, and we want, the condition is, let's just replace that with count, and it's greater or equal to the target count. Okay, not too many brackets there, but okay. Right, so let's run that. Let's see, we've got times 21, that's going to really blow it out. Okay, let's just times 2. Okay, so that's generated a count for every row. Okay, so the next one after that one looks like it will work it out. Okay, so let's now bring in a multi-row formula, and we can work out the date of each of them, because we've got every 23 hours cells divide every 23 hours. So let's do that. So we can use the existing field of date, and we want to do the nearest, I think, and we want to take the previous date. I think we want to but we also want to function it. We want to do. Let's just copy that. Replace it with a date function, take time add, and paste that in there. And then we want to 23 hours. Okay, so that should then give us every 23 hours. There you go. So we have the first start date. Now that start date is the next date. Okay, so it's already added it on from there. Okay, so, and we've not quite reached the number either. So I'm thinking this row count needs to go beyond this target count. So let's do that. And times 2. I'll get it to the next one after the one time after it. Let's run that, see, just to check. Yeah, so now we're at over 12 million. We're at 16 million. Okay, and but it's a date. But we start on the date day 23 hours too soon or too late. So let's just change that to be so if we take date, no, we do exactly the same thing where we do the date time add, and then we'll take date. Okay, and what we'll do is minus 23. So for each one, we'll just put it back to the hour it's supposed to be. So hours like that, and then run that, because that's you can see that's put it back on the 19th of March. So let's run that. So we now have the first date is 19th of March, which is the same as what we started with, and then the last date is where we've gone over the target is the 1st of April at 7 o'clock, which is the date that we've got in here, which you should be looking for. Perfect. So if we just summarize, or use the summarize tool, and what we want to do is date min and date max. What did they call it here? What was it we're looking at? Begin date, end date. Okay, so begin date, end date, and then if we just bring in browse, that should give us our answer. There you go. Why have we got a different number there? What is... That's interesting. So in here we've got a different date. That's a bit weird, because that would mean... That can't be right, because that would be one division. Okay, so this must be right, because that's our start date. Okay, that's thrown me. Alright, okay. But I'm sure this is right. That can't be right, because it would only be one 23-hour period. That anyway. I'm sure this is the answer. Thank you very much for watching. See you again next time.